The last time we used some bootleg filter papers. So, all right. Can everybody hear me? That's on the stream. I mean, got 30 people logged in.
Yes.
All right, cool. I'm going to share my screen and go over a couple of things right quick, and then we're going to jump right in and start working. I don't want to secure Wi-Fi. It's coming up. There we go. All right. So we've done the aspirin synthesis. So today we're going to do the purification part. All right. Aspirin is a solid. Take these gloves off so I have them right on the screen. Nerves? Nerves? Okay. No, you're all right. I'm just messing with you. I do that too. So today we're doing aspirin purification. All right, so it's a solid. So there are several ways to purify solids, but today we're going to do a process called recrystallization. And you've seen if you watched the video that I sent you already, recrystallization is a process where you take a solvent that your compound is insoluble in at room temperature. So that's the key to using this technique. So at room temperature, your compound needs to be insoluble. But at higher temperatures, it should dissolve. Right, so higher temperature should dissolve. So what we're going to do is take aspirin, which we made last week. It's crude, but it's still aspirin. And the purpose of the recrystallization is, let me go back up to the reaction. We made acetylsalicylic acid, which is the product, right? But there still may be some acetic acid left over, and you can smell it. It smells like vinegar. And there may still be some acetic anhydride left over. So we need to get rid of all of that stuff. So acetic anhydride, excuse me, and acetic acid are both going to be soluble in ethanol. But once we dissolve up the aspirin by adding hot ethanol to it, and then we add cold water to it, it's going to cause the aspirin to crash out or precipitate, but the other stuff will stay stuck in the ethanol layer because aspirin itself is insoluble in ethanol and water mixed together. So that's what we're going to do. So we're going to heat up ethanol. This is the procedure, right? We're going to heat ethanol. We're going to add.
Do you know any psychology majors? Who? Psychology majors?
Who was a psychology major?
I'm asking you if you know any.
So we're going to add hot ethanol. This is important that it's hot. It's got to be hot ethanol. It can't be room temperature because the purpose, again, of recrystallization is purification. And if it's at room temperature and your stuff doesn't dissolve, then you're wasting time. So you got to add hot ethanol, which we're going to heat up on a hot plate. One point of caution, do not overheat it. If it starts to boil, take it off and sit the flask on the bench top. If you put your hand on the bench top, you'll feel that it's cold. This material is designed to transfer heat rapidly from hot, glassware like beakers, flasks, and things like that. So if it starts to boil, you want to take it off, but you want to keep it hot. So you're going to add hot ethanol, and then that flask with your aspirin and ethanol, you're going to continue to add hot ethanol until the aspirin dissolves. All right. And you want to keep it heated. One of the common mistakes is to add the ethanol and just sit the aspirin on the bench top. No, once you add your initial amount, you want to put that flask plus the aspirin plus the ethanol on the hot plate and just keep swirling it. And you'll keep adding ethanol, which you'll also have on the hot plate, continuing to heat until everything goes into solution. So you want to add until everything is in solution. Everything is dissolved. All right. Questions about that? Right. It's really important not to add too much ethanol, because if your solution becomes super saturated, it's going to take longer for those crystals to form. So we're going to start out with 25 mils. So everybody's going to get 25 milliliters of ethanol that you're going to heat up. And once we start heating it up, once it gets close to boiling, that's when we're going to add the initial 10 milliliters to the aspirin sample. So let me join. Any questions about anything?
We're still filling out the data sheet.
We'll have a bird's eye view and not a static view. And then we'll get to move. Stop sharing. Come on. Let me get there. Right.
Recording in progress.
Okay. All right. So we're going to take the aspirin samples from last week, and we're going to use those samples for today to purify. So we got 4 samples. I actually took one, took one sample from the Wednesday class, so we'll have enough for everybody to use. So what I want to do now, I need everybody to get a graduated cylinder off the cart, and we're going to measure out 25 mils of ethanol. So I need to Okay, so go ahead and pin. You'll see my second login is Albert's iPad. Go ahead and pin that video, because otherwise it's going to get lost in the sauce. Let me do that over here as well. All right. So you should see it says Albert's iPad. Go ahead and pin that if you're streaming, and that way you don't have to look for it. You'll be able to follow. We're gonna measure out some ethanol. So let me put the on my pen. Always one. I always have to have one person that's, you know. So I'm gonna put enough for everybody to get 25, but and if you on that data sheet, excuse me, you'll see on the data sheet where it says how much ethanol you added. Make sure that's accurate. It may not take the whole 25. It may take 15. It may take 20. So go ahead and measure out. And this is ethanol, by the way. It's not it's denatured. So if you drink it, you'll get sick. Not the ethanol that is gonna be flowing at homecoming. It's a different kind. It's got some stuff in it to make you sick if you drink it. All right. So just take 25 mils. All right, so everybody should write that value down somewhere that we all began with 25 milliliters. That doesn't mean that it's gonna take the whole 25 to dissolve up the aspirin sample. That's close. Oh, that's good. That's really accurate. So go ahead and take that, put it in that 125 Erlenmeyer and start heating it up. No. Yeah, one of those. Just put it in one of those and start heating. And we'll pass that back. Put that on a hot plate and turn the hot plate. I will put it on somewhere between 1 and 2. And while we're doing that, you can see here, this is a crude sample of aspirin. And this is probably a really good sample. You can see how shimmery it is, kind of like shiny looking, metallic looking. That's good. If it's clumpy and dry looking, that's bad. That's a bad sample. So this sample right here is actually it's probably pretty clean already, but we still have to purify it. All right. So each group is I'm gonna bring samples around. And this is an example of what I'm talking about right here. If you can see the difference, how dry that is. Let me get it. See how dry that looks and clumpy. That's not good compared to that. And y'all see that? See how that's all shiny looking and shimmery looking, and that's not. This is probably crap. But when we recrystallize it, that'll help. That'll make both of them pure, right? So I'm gonna leave that with you. You can take that sample and you're gonna save it. You're gonna bless it. It's brand new right now. And then what about you? All right, so while the ethanol is heating up, what we'll do is take the aspirin sample and transfer it to the other Erlenmeyer. So take that other 125. You're gonna take this and just fold it over like so. Put that in there. All of it. Oh, leave. Never mind. Transfer all of it, and then what's left on the paper, we're gonna save. We're gonna save a little bit for the melting point because we want to be able to compare the crude melting point and the pure melting point. So whatever is left on the paper, we'll save to check the crude melting point. All right. It's gonna work. It's gonna work. Don't doubt yourself. Have confidence in your abilities that you've never used before. It's gonna work. All right. Anybody have any questions that's streaming right now? Anybody have a question about anything? So what we're
Yes,
doing-
I have a question.
Go ahead.
So in the video that we had to watch, it says specifically for the demo part, the instruments that we would use is the NMR and the IR. What does that mean?
Yeah. So that's later. We're actually going to do NMR on aspirin. That's a nuclear magnetic resonance. It's actually an instrument that you can take a sample of aspirin, put it into an NMR tube, and that instrument will give us an idea of the carbon hydrogen framework. So if we do proton NMR, we'll see all the hydrogens on that aspirin and where they're located. But we're going to do that later. We're not doing that in this experiment.
Okay, thank you.
Video was just to give you an idea of the process of recrystallization. So taking a solid, and we're not using boiling chips or boiling sticks, but taking a solid, adding a hot solvent to it, and then dissolving it up so that we can dissolve it and then precipitate it out by adding cold water to it. But we
Okay.
are going to use NMR. It just won't be for this experiment. And if we get a chance to do infrared, we'll do that too. That's a totally different experiment. Infrared allows you to see different functional groups like ketones, alkenes, alkynes. All these different functional groups have different infrared stretches, absorbances, and so that allows you to see them. So we'll do both because we do have a FTIR up here. Oh, we haven't added any yet, Tia, but everybody's starting with 25 milliliters. All right, so I'm gonna go around because I think I'm gonna show how far everybody's working. Here, got everybody's transferring that aspirin sample. Now, that sample, I think was somebody screwed up and added too much. I'm gonna add 10 more mil. All right. Yeah, that was we had one sample from Wednesday that somebody added too much salicylic acid. They started like almost 8 grams instead of 7. But we got a suggested amount of you can see here, hopefully that's a so you can see here, this is another sample of aspirin. It's kind of dry, funky looking, so it's probably not very pure, but we're gonna take care of that today. All right, ethanol is about water, so heat the ethanol. You see it here, right? Once it starts boiling, that's when you want to take it off. So now what you want to do is add the first 10 milliliters to your aspirin. Because it's hot enough now that you can add 10 mils. On this envelope. You can see right away that's already dissolving some. So now you want to start heating that up. Right? You want to keep that swirling, and then you also want to keep the ethanol hot as well. Right? You don't want to add cold ethanol to it because it's going to stop the process of it dissolving. So keep swirling. When that starts boiling, take it off. All right. Everybody good? Let's see what your ethanol is doing. Not quite good. Right. And if you want to turn it up to about 2.5. All right, one of the things about this ethanol, I need a steady cam. If you overheat it, it will ignite. All right, I'm just telling you. So don't overheat it. I've had that happen before in a lab. Student was just sitting here chilling, writing notes, not paying attention, and the whole flames were shooting out of the top of it. And they didn't even know. They were totally oblivious to it. So do not overheat it because it has a low flash point and it will ignite. All right. You're already nervous. And now it makes more nervous. You already like, you already shook and now it messed you up like, oh Lord, please, no, don't let mine blow up. It's not gonna blow up though. I'm all right. With a small group, I can pay attention to everything. So it's not gonna blow up. This was before COVID. So we had like 25 people on each side. You can lift it up and swirl it, but Yeah, you could turn the temperature down too. Is it dissolved all the way? Okay, do you have any particles left in there? Nothing. Sorry. Oh, no. Okay, no solid, take it off. You can turn the outlet off. All right. So for one sample, that was about 10 or 11 milliliters, and everything dissolved. Is that right?
Yeah.
All right, so make sure you make a note of that. So the actual amount of ethanol used for your sample was about 11 mils. So now we know it's in the ballpark how much ethanol is going to take to dissolve up the aspirin, close to 11 or 12 milliliters. And let me take the camera back here again. And hold this sample up the top line. You can see here, most samples is dissolved. There's no solid left. That's what you want. But if she had added that ethanol cold, then it would be free. So we're gonna let that cool to room temperature. We're gonna add some cold distilled water to it. Like 20 mils. That's not what you can call for. Does not work. Not get hot. You can turn it up some more, or you can use her. Just slide that on through that on that other side. We're gonna repurpose some stuff.
It's warm.
You can turn it up. All right.
We can barely hear you when you step away from your other computer.
What about now?
We can hear you now.
All right. I'll try to talk louder when I step away. I don't want to turn the audio on the iPad 'cause it's going to echo and give feedback. I need a mic. I need one of those little preaching mics that, like the TV preachers wear. All right. So with that sample that's in the back, go ahead and take some cold water. It's up here in the cooler. Bring your beaker too so you can make your ice bath. No. Right there. Yep. What you had. So you want to make an ice bath. You also want to take some cold still water. All right. I'll pour that. Oh, it's just water. So you can add the cold water to your sample. Is yours heated up? Hold up. I'm coming back. You have your mic muted on your phone? Yeah. Hopefully it won't. All right. So now we have an ice bath set up. We have the aspirin set up. And she has cold 25 mils of cold distilled water. So go ahead and add the water to the aspirin. And it should cloud up. You should see it get cloudy. Let's do it. Add all of it.
It was more than 25 minutes.
Let's do it. All right. So now you see that got cloudy. That's on purpose because aspirin is insoluble in ethanol and a mixture of ethanol and water. So what you want to happen now is you want your crystals to come out of solution, but you want them to come out slowly, not rapidly. All right. So we're going to sit this down in the ice bath like that and leave it. Don't disturb it. When you recrystallize it, what you don't want to do is what you don't want to hurt the crystal by that point. So we're still waiting on the other groups ethanol to heat up. Yours is getting close. Yours is too. You can see the waves going through it. Yours is close. I can see that from here. want it right before it starts boiling. So as soon as you see it boil, you can take it off and add about 10 milliliters to your sample. And you do have your aspirin in a, yeah, you got it, yeah, in a flask. All right. Any questions? Yeah. You can take it. Don't transfer, just eyeball it. Nope, what is that? What's in the other flask? The big one that you have in your hand? Yeah, what's that? Don't use that. Take that small flask that you have, that's boiling, and transfer 10 milliliters to the aspirin. Yep. So about 10 mils. Just add some more because that's not gonna be enough. All right, let me see what you got. Add a little more. Is it a slurry or is it still solid? No, I see the, yeah, you can put that on the hot plate now and start swirling it. Just sit it down and swirl it, yep. And keep your ethanol close by because if you may have to add more. And you can sit the ethanol in the corner of the hot plate to keep it hot. What's your hot plate set on? What temperature? Yeah, you can turn it down so it doesn't boil, just stay hot. Yes. Turn yours up another half. Keep going. All right, you can see on this side. All right, with this sample, you can see that it's somewhat dissolved, but not all the way. All right, so what you want to do is keep heating, keep swirling, and if it doesn't dissolve, then you can always add more ethanol. Keep adding enough till it all goes in solution.
Do I have more?
Yes. Oh, wrong way. That goes in there.
This goes in
Yeah, the liquid goes in with the aspirin, not the other way around. All right. Add some more because it's still. Go ahead. I'll tell you when to stop. All right, that's good. Now sit that on the hot plate and swirl it. You're gonna have to add more. It's not. That's still not enough. All right, there you go. Now swirl it and keep it hot and keep your ethanol somewhere. Might not be enough room. Just have to swirl in smaller circles. If that makes sense. All right. It all dissolves, so take it off. Bring your graduated cylinder. Take the ethanol off, turn the hot plate off. How much did you end up using? It started at 40, right? Right at 10? Okay, so we're gonna say for your sample, you use 10 milliliters. Praying for your ethanol. It just ain't doing right. About 11 or 12 mils, all right. So we're seeing now it's taking roughly about 12 milliliters of ethanol to dissolve these aspirin samples, which makes sense because we were supposed to start out with 13.8 grams of aspirin, and that normally, based on history, would take about 25 mils of ethanol. So you expect it, since we cut the aspirin amount in half, or cut the salicylic acid amount in half, it should take about half the amount of ethanol to dissolve up the crude sample. Just keep swirling. Go ahead. No, don't unhook it. Go ahead. Slide it on down. Leave it hooked up. Because we know that one right there is the 5 right there. We already know. So you need to come and take some. There you go. Slide it down as far as you can. You can see on this, with this sample, it's not quite dissolved, but it is going into solution. And you always want to keep that ethanol hot. So you have to add more. It's hot and not room temperature or cold. Right, you might want to add a little bit more ethanol. Let me find a glass rod too, because we can break those chunks up as well. See that? Like that. See it? So you can just work on that side. Almost. About 10 seconds it will be. All right, and we're gonna take the, again, we got this 4th sample. Let's look at the other sample that's already been added to the ice bath. Come right out. The crystals form fast, that's bad. You want your crystals to be slow forming, not rapid forming. All right, the slower they form, the more pure the aspirin is going to be when it comes out. You need to add some cold water to that. 20 mils. Take that graduated cylinder, got cold water right here. And you can set up 25 mils of cold water. Can you pass me his beaker? Thank you. Close. It looks like it's all dissolved now. You can take the ethanol off. How much did it take? Rough. What's left? What you got? Oh, the gradations on here are terrible. But it was 25. You started with 25 though, right?
Yeah.
Pour was back in here, pour back in the cylinder. Let's take the difference, see what we got left. It's about what, 10? Yeah, so it took about 15 mils. So you can take that off the hot plate and turn it off. I think you ready now. So that last sample took about 15 milliliters. See, the good thing about going last is that you've seen what to do, so you're good. More. More. You want to at least get it to where the sample is covered. Right there. Now put that on a hot plate and swirl it until it goes in the solution. And then you can put the ethanol on the back corner so it'll stay hot. And if you need to add more, you can. All right, go ahead and add that water to your aspirin. And then, there you go. Add all of it. Did it go cloudy? Somewhat. All right. So now you can sit that on the ice bath. And now it's a waiting game. in the cylinder, the graduated cylinder. Do you see any crystals forming? No, charge. You see anything forming yet? A little bit. If you don't, then you'll see it. It'll come. You can add more ethanol if you need to. Tell me that again. Also, wow. This is really like art. Recrystallization is art. Like so easy to so critical to pick the right solvent. If you work with something other than aspirin, there's a range of solvents you can use. It's really critical to pick the right solvent. Otherwise, you have to do. Just put about 100. That's what you want, right? You don't want them to start right away because again, the faster those crystals form, the more practice is coming in technology. The slower they form, the more pure that aspect is. That's why we're gonna use NMR because we want actually be able to see everything that's in that. Check it out. And you can add it. Okay, you can take it off. Let it cool down to room temperature. Go ahead and get your water and your beaker. Did I give you a beaker? All right, any questions from anybody?
Someone typed the question in the chat.
Okay. How long would, I see a question from Sanaya about the time. I didn't calculate. Was anybody calculate time? What? No? We're gonna estimate, I'm basing on your sample. We're gonna estimate that it took about 3 minutes to dissolve. Yeah, just put it up to about 200. Not that water though. That's the good water. Yeah, use out the tap. We'll say it took about 3 minutes. So the average amount, we're just gonna average it. Took about 12 milliliters of ethanol. And then the estimated time is about 3 minutes to dissolve. Okay, so the crude yield, we need to know which of the two reagents. Oh no, I take that back. For crude yield, let me weigh a sample and give you a crude yield. Because what we should have done at the beginning was to take each sample and weigh it to see what the crude yield was, because that's just the yield before recrystallization. But I'll take one of the samples in the drawer and we can use that value for the crude. So give me a second. I got to go get a weigh boat. All right. 1 second. Yes. All right, so I'm measuring a sample now, and that we'll use that number for the crude yield. I just need to weigh it out. Because I think there's a space on the data sheet for crude yield, is that right? Yeah, so we'll take this number here. All right, so crude yield, the number that we're gonna use is 6.95. All right, so that's the mass of your sample before you purify it, right? 6.95 grams. Got to see that. All right, so we got a problem, a fixable problem, but a problem nonetheless. So sometimes you can add too much ethanol. Oh, might be the, what they call it, the northern lights, or aurora borealis, or whatever it is. So with this sample, I don't know, hopefully you can see that. Right, we've added 40 mils of water, we added ethanol, but there's not much happening. So I think we may have added a little bit too much ethanol. So the way to fix that is there's a couple of things you can do. You can scratch it with a glass rod, scratch the side to kind of accelerate crystal formation, or you can seed it. So that's what we're gonna do. We're gonna take a little bit of aspirin from somebody else's sample and drop it in there. And that little piece of aspirin is going to be a lattice, and all the other crystals are going to grow around it. So we're going to see that. I'm just going to take a little bit of aspirin. I'm going to take the charge because we got a lot. Right? And I'm going to add this to your sample, and I'll bet money, because y'all don't believe me, probably like, it ain't gonna work. So I'm only adding this a very small amount of aspirin. I just need a couple of crystals in there for her crystals to grow around. I'm gonna add that. And in a few minutes, you're gonna see her stuff start crystallizing. Tell me your name in the back. Maya. All right, so we're gonna get you set up with a back filtration. What is about that? That up to that aspirator over there. We want basically all the same. Take it out. Might want to turn the water off. Wait. We got it. So I don't know if you can see those little crystals at the bottom of this. Let me get that in the camera. But there are actually now some crystals starting to grow. Very small amount, but they are coming. Uh-oh. All right, so what we're gonna do is just leave that on the ice bath and leave it undisturbed and let those crystals do what they do. We'll leave that. We'll leave that. Can't get it. Yep. And that's all. All right. Now put the other hand, go ahead and wet this part. We can put the holes on there. Turn the water off, and let me get you a piece of filter paper. That's what we. And you want to get some more water. That would use tap water to do a filtration. What's in that water? Add a little drop of that. See this down in there. Probably pull back. Kind of pull off all the liquid from that salt. A little bit to it. Take a sample. So crystal loosened up, pour it right onto that filter. It's already got some water in it, right? Little, bang, bang it. So loosen them up. Said bang. Pat. Come on, Crystal. Come on. So you, if it's solid like that, go ahead and add about 5 mils of water. I normally would recommend taking a glass rod and breaking it up, but then you're gonna lose some sample. So go ahead and add a little bit of water to that, and then you can go more. Add a little bit more. You want to make it like a slurry. All right. Perfect. Yeah, make sure you get it in the filter paper, not on the sides, not over the sides. Right. So we've seen this before. The vacuum filtration looks like a zoom, but you can see the vacuum filtration setup. It's the vacuum flask, a buchner funnel, and then a filter adapter to create a seal. So what you want to do, yeah, you want all that. Add more water. What you want to do is take that buchner funnel and kind of press it down a little bit because you don't have much of a seal. That's why it's not draining that fast. Mhm. Not the whole funnel. Mhm. Yeah, there you go. That's good. It's still not coming. There you go. Is that big chunk not coming out? Trying. Y'all about y'all can go ahead and set yours up too. It's the back there. If this doesn't fit into the back glass, it's gonna go down like that. Some of those glass have a really thick lip around it. So it's kind of difficult to get it to fit. So we can look at this sample again. You can see it's a lot more cloudy, but the crystals still haven't started forming yet. So we're gonna seed it one more time, and then we'll see what happens. seed this again, so I'm gonna add a little bit more aspirin to this sample and try to get these crystals to grow. And again, anytime you have a solution that is potentially oversaturated, one way to fix it is to seed it. Another way, again, is to scratch the glass on the side, but I don't have a glass rod handy. So we're just gonna continue to try again to see. I can see now without action now. It's gonna, boom, just watch. Just watch. I'm gonna try both methods. I just went and got a pipette, a pasture pipette. I'm just scratching the sides of the flash. I already see some action now. Yeah, turn it over that way. Yep. So y'all got those new joints. The vacuum flasks, they have that thick lip, so it's kind of hard. And take your filter paper, that is a piece. There you go. Take that. Aspirin directly off the lip. Crystals, wanna come out. I can see some floating at the top now. I don't think y'all can see it because of the frost, but. Scratch the sides again. What other thing? 20. All right. Y'all pray for this flash. We didn't have to do a hot gravity filtration, Sanaya. Normally you do that during the recrystallization process. If something is floating around in your flash that won't dissolve, then you filter it off real quick with a glass funnel and a piece of filter paper in that funnel. Filter it, and then what's left, that's what you'll cool down, add water to, and crystallize out. But we didn't have to do it because all the samples were clean. Now, next week, we may have to filter it because this filter paper that we're using is crap. Like major crap. All right, anybody have any questions that's streaming? Otherwise, we can end the stream because everything left now is just clean up.
There's a table. Oh.
I'm
There's a
sorry.
table, you know. Okay, go ahead.
I'm listening.
There's a table between the reagent table and recrystallization. What do we put in those values there? Or are we supposed to calculate it ourselves?
You need to calculate that. So you can look up the aspirin molecular weight. You need to calculate the number of moles of each of your start materials so you can figure out which one is limiting. And then using the limiting reagent in moles, you can calculate the theoretical yield. But the number of moles of each you need, you gotta have that in order to do that next step.
Okay, thank you.
Mhm. Thank you.
I just want to make sure, can you go over just one more time everything that we needed to write down? I just want to make sure I'm not missing anything.
You mean for today?
Yes.
We wrote down the amount, on the third table, we wrote the amount of ethanol, the time elapsed during the recrystallization, and whether or not we did a hot gravity filtration, which the answer to that is no, we did not do a hot gravity filtration. And then the reagent table we filled out last week.
Gotcha. Thank you.
All right. Yes. Say again. Okay, you can take it off and let me get you a watch glass. Actually, you know what? One of these that's already up. Take the filter back off, put it on. Got the water right? Down here on the wall of mine. Back. No. Just let it, just turn the water on and then pour the sample into that, onto the filter bag. You can take that off and put it in the watch glass. Huh? Yeah, and wash it and put it back on the cart. As much as you can, because that percent yield is gonna be, if you left all that in there, that percent yield is gonna suck. I can tell you that right now. Here you go. Tamia. I was about to call you Tamaya, because I was thinking about her. Got it. All right, any other questions for anybody that's streaming? All right, if not, we're gonna log off. And I'll see y'all again. Actually, I'll see most of y'all in the morning, so God willing, but if there's no other questions, we're gonna go ahead and log off. All right, y'all have a
Have a
good
great rest of your
afternoon.
day.